British and Russian scientists have teamed up to test a combination of the Oxford AstraZeneca and the Sputnik V COVID-19 vaccines. The trials will investigate whether the combination of two coronavirus vaccines could lead to a better immune response in people. The tests are set to take place in Russia, involving volunteers over the age of 18. Moscow claims its Sputnik V is over 90% effective, which is higher than AstraZeneca's own vaccine. Well, I'm joined now by Dr. Bharat Pankhania, who is a senior clinical lecturer at the University of Exeter Medical School. Thanks very much indeed for joining us on the programme, Dr. Pankhania. So how do these vaccines work and why might they work well together?
It's a very good application of science, and I love it. I love it when scientists are thinking beyond the box. So for the benefit of our viewers and listeners, this is how it works. So with respect to the AstraZeneca Oxford Group vaccine and the Sputnik V Russian vaccine, they're very similar. The similarities are that they use an adenovirus. This is a virus that is found in the back of people's throats. That's why it's called an adenovirus. And to this adenovirus, they attach the instructions. This is the RNA instructions for the body's cells to make the RNA, to make the spike protein against the coronavirus. So the difference between the AstraZeneca Oxford one and the Sputnik V one is that the AstraZeneca one uses a chimpanzee adenovirus to get the message through into the human cell to make the spike protein. The Sputnik V one uses two versions of a human adenovirus to get the message through to make the spike protein. So you can see the similarities here. And the hypothesis, the thinking is that maybe if I give you a chimpanzee carrier into your cell to make the spike protein, as well as a human adenovirus carrier to make the spike protein, the end result will be better. So that's the hypothesis. Now let's see what happens.
So both of these work differently than the Pfizer-BioNTech vaccine. What might the advantage be of having these different types of vaccine in circulation?
So there are several advantages. So just for completeness, the Pfizer-Moderna vaccine works as a nanoparticle, a very, very tiny particle, 10 to the minus 9, and it is coated in a lipid envelope. And it is so tiny that inside the lipid coating is the message, the messenger RNA. It can get into the cell and then do what it needs to do. So when we have several platforms of vaccines, i.e. Pfizer, Moderna, AstraZeneca, Sputnik, and others, number one, we can work out which one works best. Number two, some of them are much easier to make, transport, and give. And number three, because we are making them in different places, different parts of the world, you can also have the capability to immunize a large number of people in different parts of the world using all these vaccines that all seem to work.
And there's no firm data yet on how the Sputnik V and the AstraZeneca vaccines work in older people. Is that something we should be concerned about?
Well, if and when these trials of the combined AstraZeneca Sputnik V vaccines take off, they will test it out in a good representative group of people, the elderly, the vulnerable, the young, in between, etc. And then we will see. But thinking empirically, from first principles, I can see, yes, there is merit in trying this. And yes, I wouldn't expect it not to work at all. What will be interesting is how well it works.
OK, Dr. Bharat Pankhania from the University of Exeter Medical School, thanks very much indeed for joining us on the programme.